There are three columns of information in this data set. The first column, column A, is simply an identification number for each of the 50 individuals who took part in this particular study. In column B, we have the number of hours that each of those individuals said he or she had spent watching television during the past week. And finally, in column C, we have each individual's percent body fat. Now what we're going to do is use a statistical technique called regression to see whether there is a relationship between how much time somebody spends watching television in a given week and the person's percentage of body fat. The best way to get a handle on what's going on here is to look at these two columns of information in a visual way. And I've done that here on the scatter plot tab. So what you see here is on the X or horizontal axis, we have plotted the number of hours that each individual spent watching television. And then here on the Y or vertical axis, we have each individual's percentage of body fat. Now, each of these blue diamond shapes here represents one or at least one individual in the data set and shows you what that individual's number of hours spent watching TV was and what that individual's percent body fat is. So for example, this person here spent about 50 hours last week watching television, a little bit more than 50 perhaps. And then over here, this person has about a 35, just a little under 35% body fat. For comparison, we have this person down here who has a fairly low, relatively low number of hours watching television. Just looks like just a little more than 0, maybe 1 or 2 hours watching television, and also a very low percentage of body fat relative to the others. Looks like maybe about a 12% or so. All right, and all the other individuals are arrayed sort of in between those two extremes. And notice how there's kind of a trend or a direction here. All of the individuals collectively sort of are lower on this end than they are on this end. And in fact, we've got a black trend line here running through them. This is the regression line, which you'll learn more about later, that kind of shows what the overall pattern is. So generally speaking, as the number of weekly hours spent watching TV increases, so does the percentage of body fat, at least among these 50 individuals. Now, regression is going to tell us, first of all, how strong this pattern is, and whether that pattern is strong enough to suggest that the pattern exists for some non-random reason. There's one more thing on the chart here that I want to point out, and that's this number here. This R2 equals 0.5577. Regression produces a statistic called a Pearson's R, and a Pearson's R ranges from -1 to +1. Now, if the Pearson's R is negative, it means that this trend line here is higher on this end than on this end. In other words, it means that the trend line slopes downward as you go from left to right. And that means that as one variable gets larger, the other variable gets smaller. Okay, but if the Pearson's R is positive, that means that the line looks like this one, that it angles upward as you move from left to right, meaning that as one variable gets larger, the other one gets larger as well. Now, I said that a Pearson's R can range from -1 to +1. That means it's possible to have a Pearson's R that is close to 0. What that would mean is that, see how all these points are kind of arrayed around the trend line? A Pearson's R that is either a perfect -1 or a perfect +1 would mean that every one of those points fell exactly on the line. Okay, whether the line is sloping up or down. As the Pearson's R approaches 0, what happens is these points move farther and farther away from the trend line and get more and more kind of circular. Also, the line itself would flatten out. So a Pearson's R of 0 would look like a nearly flat trend line, and all of the data points arrayed in a basically random and circular pattern around the trend line. And what that tells you is that there's really no relationship between these two variables, that you can't really predict any one variable from the other. They just don't have a relationship. Now, this R squared statistic that you get can be computed simply by squaring whatever that Pearson's R is, by taking it and multiplying it by itself. What that does is that of course makes the negative sign go away, because any negative number times another negative number produces a positive number. Okay, so R squareds are always positive. What it tells you is the percentage of variation in one variable that can be explained by knowing the other variable. So for example, if I want to predict any one individual's percentage of body fat, if I know how much time they spend watching television, okay, I can be about 55% more accurate in my estimate of their percentage body fat than I could be if I did not know their percentage body fat. Okay, so to say that again, perhaps a little more simply, the R squared tells you the percentage of variation in one variable that can be explained by the other, or about the percentage more accurate you can be in predicting one variable if you know the other variable. Okay, so a quick introduction there to the meaning of regression and some important concepts. Let's go back and see how to at least get started producing one of these things. Again, you start on the Data tab and choose the Data Analysis button. And on the drop-down menu, look for regression. Where is it? Ah, there it is. Looks like this. Okay, regression. Just choose that and click OK. And of course, we have ourselves a dialog box here to fill in. The Y range would be the range that you think is the result in whatever the relationship is. Okay, that would be the percent body fat column here. So I'm just dragging and highlighting, again, including the label at the top. And the input, or the X range, would be the variable that you think is the cause. Okay, and that would be, in this case, weekly TV hours. We think that it's watching a lot of TV is what tends to increase the body fat here. That's our theory anyway. Okay, so we have that. We need to tell Excel that there are labels at the top of the data columns that we highlighted. So I made sure the labels box is clicked. The output range, I'm going to have Excel put the output right here in cell E1, or at least starting there. And then down here, we need to check the residual plots button, and I'll explain that a little bit more in a minute. Okay, quick last check. Everything looks fine. Let me go ahead and click OK here. And we get a lot of output in this case. Let me go ahead and expand all of this so we can see what we have. All right, so there's the Pearson's R that I was talking about. It gets labeled as multiple R, but that's it. It's 0.74. So we can tell from that the relationship is positive. That is, as one variable increases, so does the other, and that it's actually fairly large. The 0.74 is almost 3/4 of the way from 0 to 1. So that's a fairly large Pearson's R. There's what you get when you square it, about 0.55. That's the same figure you saw on the chart just a minute ago. And the question of whether that relationship is strong enough to suggest that it's non-random, that gets answered right here. We have a fairly small number, 9 zeros, and then 0.473 and some change. So that's a whole lot less than 0.05. And that suggests that the relationship we're looking at here did not occur at random, that there's some non-random reason why that relationship exists. Okay, so that's how to compute and interpret a regression equation. In the next video, more on how to interpret some of this other output down here.